for a vacation that is soothing and relaxing with an amazing view? Well, what view could be better than a view of the galaxy? Come on this vacation and you will get a view of the main sequence and all of the stars within it. Different sizes ranging from a tenth of the sun size to 200 times as big. Why should you come on this vacation? So many reasons. These stars fuse hydrogen to form helium atoms in the core. On this vacation, you will see them start out as clouds of dust, and then, because the inward pull of gravity is balanced by the outward push of pressure, the core is condensed. You will see the core become hot enough so that the stars will be able to undergo fusion. These stars' lifespans depend on how massive the star is. For example, the more massive a star is, the shorter its lifetime is, because it burns through its supply of hydrogen faster. Also, the more massive a star is, the greater its luminosity is, so bring sunglasses for this cruise. On this cruise, we will visit our well-known neighbor, the Sun, who is a star in the main sequence. The Sun is an average-sized star who is expected to live about 10 million years and is about halfway through its lifetime. All these stars that you will see on this cruise are a part of the main sequence, and they will leave the main sequence once they burn through all of their hydrogen. To be a main sequence star, you have to be fusing hydrogen in its core and have a stable balance of outward pressure from core nuclear fusion and gravitational forces pushing inward. These stars varies in color, and the color determines the temperature of each star. For example, the hottest stars are blue and the coolest stars are red. So please, come join us on this amazing cruise through the main sequence. You won't regret it. Are you looking for an adventure that's a little more out of your comfort zone? This safari may just be perfect for you. Come on a safari through all of the stars outside of the main sequence. On this safari, we will encounter red giants, planetary nebulae, white dwarfs, and black dwarfs. First, we will venture near some red giants. These giants have layers of gas around it that cause the star to expand and grow drastically. They have lots of energy and are very bright. They are red because they have grown cooler over time. When our sun leaves the main sequence and becomes a red giant, it will become 400 times its size, and the rocks will melt and oceans will evaporate on Earth. After visiting the red giants, we next head over to see some planetary nebulae. These form when the surface layers become unstable. 1 centimeter cubed weighs 1 ton on Earth. The ejected surface layers of the planetary nebula spread out over time, mixing back into this interstellar medium. Next, we'll head over to see some white dwarfs. These are about the size of Earth and shine due to the stored heat, not fusion. Finally, we will head over to black dwarfs, which are made up of a carbon core that has cooled over time. They are very dim, and on the visible spectrum, they range from the colors white/blue to yellow to red. Eventually, these dwarfs will reach an equilibrium with the universe. So come, explore the universe with us on this safari. None of these vacations sound right to you? Are you thirsty for adventure? Then come on the expedition. On this journey, we will venture out to the dangerous supernovas, neutron stars, pulsars, magnetars, and black holes. Our first stop will be the supernovas. A supernova occurs when the gravity overwhelms the pressure in the core and it collapses on itself, followed by a violent explosion. Gold, silver, nickel, zinc, and uranium are created in the explosion. Supernovas can be so bright that they are visible during the day, or in some cases outshine their galaxies. After these, we will then go visit some neutron stars. A neutron star is a tightly packed ball of neutrons created during the implosion stage of a supernova. Did you know that only a teaspoon of this star would weigh more than all of humanity? Models of this star show that it would have a solid surface. And we'll make sure to maintain a safe distance because the gravity on these stars can flatten a human thinner than a piece of paper if you stood on it. After this, we will then visit what are known as pulsars. These are defined as rapidly rotating neutron stars that emit highly regular energetic bursts or pulses of light. They spin 3 to 30 times a second and get their energy from spinning. All pulsars are neutron stars, but not all neutron stars are pulsars. They emit mostly radio waves, but also emit visible X-rays and gamma rays, and their pulses are regular. About 1,500 pulsars have been discovered in the Milky Way, and when they were first discovered in the 60s, they were thought to be aliens because of how deliberate the pulses looked. And after visiting a pulsar, we will then go see a magnetar. A magnetar is a neutron star with an exceptionally strong magnetic field that spins and emits pulses of light, but they differ from pulsars. Only 5 have been discovered in the Milky Way so far, and they spin up to 200 times a second. Because the magnetic field is so strong, it acts as a brake and slows the spinning. They only live about 10,000 years, significantly shorter than a star's life, so enjoy it while you can. The magnetic field is 1,000 trillion times stronger than the Earth's magnetic field, and 100 times stronger than any other magnetic fields on the universe. If you get too close, it would instantly rearrange every atom and molecule in your body. To be safe, you have to stay a light year away. Our last stop will be the famous black hole. These black holes are so dense and the gravity is so strong that the escape speed exceeds even light. A black hole is formed if the neutron star has more than 3 times the mass of the sun. It will then collapse and nothing can stop it, and become a black hole.